Find a function f defined by a polynomial of degree 3 that satisfies the given conditions. -2 is a zero of multiplicity 3, and f of -1 equals 4. So when you see that term multiplicity, it simply tells you how many times that particular zero occurs. So this zero of -2, it occurs 3 times, multiplicity 3. So basically when you write it in linear factor form, it's going to be x plus 2 with a little 3 as its exponent on the outside, meaning that it occurs 3 times. So it's going to look like so. Now we still need to find a, because again, a tells you not only in behaviors of graph, but it also tells you if there's any stretching or compression or whatever that's going on. So let's find a. To do that, we're going to plug in the value they gave us. They gave us an input, an x value of -1, and they gave us an output, a y value of 4. So we're going to remove f of x and replace it with 4. We're going to remove the x and replace it with -1. When we do so, it's going to look like so. We're going to go ahead and do the math inside. 1 multiplied 3 times is still going to be 1. 1 times a is simply just a, so a equals 4. Putting it all together, this is our polynomial in linear factored form. Now in your homework, if you're asked to write it in standard form, then you'll need to go through the multiplication process. So recall this one, 0 has a multiplicity of 3, which means you have 3 of those. So you can write it in expanded form. It would be x plus 2 times x plus 2 times x plus 2. Start by doing FOIL, first, outer, inner, last, multiplying 2 of those binomials. That's going to give you a trinomial. Then multiply the trinomial with the binomial to give you a polynomial. And then lastly, distribute the 4 to each term of the polynomial, and then you'll have your answer in standard form.